Welcome. Today's video is going to be interesting. Many of us are acquainted with factorial, but do you know more different types of factorials exist? We will discuss 10 types of factorials. First, let us introduce those. These are factorial, multifactorial, subfactorial, alternating factorial, exponential factorial, hyperfactorial, superfactorial, primorial, swinging factorial, and the last one is falling and rising factorial. Stay with us at the end of the video. You will surely learn many interesting topics. Let's dive into the explanation. The first one is factorial. The factorial of a non-negative integer, n, is the product of all positive integers less than or equal to n, is denoted by the exclamatory sign after the number. N factorial is equal to n times n minus 1, and so on up to 1. For example, 5 factorial is the product of all positive integers less than or equal to 5, and it is 5 times 4 times 3 times 2 times 1, which is equal to 120. Let's discuss multifactorial, which is the generalization of factorial. First, break down double factorial. The double factorial of a number n is the product of all the positive integers up to n with the same parity, odd or even, is denoted by double exclamatory sign after the number. Same parity means the double factorial of an even number is the product of all even numbers, and the double factorial of an odd number is the product of all odd numbers less than or equal to the number. For example, 8 double factorial is 8 times 6 times 4 times 2, which is 384. And 7 double factorial is 7 times 5 times 3 times 1, which is 105. Keep in mind that n double factorial is not equal to the factorial of n factorial. 3 double factorial equal to 3, where factorial of 3 factorial is equal to 720. The multifactorial of a number n is the product of integers decreasing by a fixed step, k. It is written as k subscript or superscript of the exclamatory sign. Multifactorial of n can be written as n multiplied by n minus k, multiplied by n minus twice k, and so on, where k is the step size. In case of double factorial, the step size is 2. Similarly, for triple factorial, step size is 3. For example, 8 triple factorial is 8 times 5 times 2 equal to 80, where each number decreases by 3 from the previous one. If the step size is 4, it is known as quadruple factorial. 9 quadruple factorial is 9 times 5 times 1 equal to 45. At number 3 comes subfactorial. It is denoted by exclamatory sign before the number. First, understand the concept of the subfactorial. Subfactorial is the number of ways that n objects can be arranged where no object appears in its natural position. This is known as derangements. Let's consider a set of 3 objects. There are exactly 6 ways that 3 objects can be rearranged. Orange color is used to indicate that the object is in its original position, and blue color is used for shifting position. There are only 2 arrangements where no object is in its original position, the 4th and 5th arrangements. So, the subfactorial of 3 is 2. Mathematical formula for calculating subfactorial of n is equal to n factorial multiplied by summation of negative 1 whole to the power I over I factorial from I equals to 0 to n. You can also verify using the formula that 3 subfactorial is 2 by putting 3 in place of n. Details calculation is shown here. Let's talk about alternating factorial. The alternating factorial is the absolute value of the alternating sum of the first n factorials of positive integers. It is denoted by AF of n. Alternating factorial of n is equal to negative 1 whole to the power n minus I, multiplied by I factorial, from I equal to 1 to n. If n is odd, the even index factorials multiplied by minus 1. And if n is even, the odd index factorials multiplied by minus 1. Let's see some examples. Alternating factorial of 3 is 1 factorial minus 2 factorial plus 3 factorial, which is equal to 5. Alternating factorial of 4 is minus 1 factorial plus 2 factorial minus 3 factorial plus 4 factorial equal to 19. At number 5 comes exponential factorial. The exponential factorial of a positive integer n is raised to the power of n in a right grouping manner from n minus 1 to 1, also known as expofactorial. It is the exponential version of factorial. Mathematical formula is n to the power n minus 1, continuing up to 1. Recurrence relation of exponential factorial is a n equal to n to the power a, n minus 1. For example, exponential factorial of 4 is 4 to the power 3 to the power 2 to the power 1. Simplify it from right side. 2 to the power 1 is 2. Then 3 to the power 2 is 9, and 4 to the power 9 is 262,144. Let's move to the hyperfactorial. The hyperfactorial of a positive integer n is the product of all integers less than or equal to n raised to the power of itself. It is denoted as h of n. Mathematical formula of hyperfactorial of n is equal to 1 to the power 1 times 2 to the power 2 times and so on up to n to the power n. For example, hyperfactorial of 3 is equal to 1 to the power 1 times 2 to the power 2 times 3 to the power 3, which is equal to 108. Here, each number is raised to the power of itself up to 3. Let's talk about superfactorial. There are two different definitions of superfactorial. First, consider Sloan and Plouffe's superfactorial. Sloan and Plouffe define the superfactorial of a positive integer n as the product of the first n factorials. It is denoted as SF of n. Superfactorial of n is 1 factorial times 2 factorial, and so on up to n factorial. For example, superfactorial of 3 is 1 factorial times 2 factorial times 3 factorial is equal to 12. Let's discuss Pickover superfactorial. Pickover defines a different superfactorial, one that involves compound exponentiation. It is denoted by $symbol. Superfactorial of n is equal to n factorial tetration of n factorial. This equals n factorial compounded exponentially n factorial times. Do you know what is tetration? Tetration is the repetitive exponentiation. It is written as left side power. N tetration of a means is raised to the power of a n times. For example, the third tetration of 2 is equal to 2 to the power 2 raised to the power of 2, which is equal to 16. Let's move to the example of superfactorial. 2 superfactorial is equal to 2 factorial tetration of 2 factorial, which is equal to 4. Another example, 3 superfactorial is equal to 3 factorial tetration of 3 factorial. 3 factorial is equal to 6. It stands 6 tetration of 6 means 6 is raised to the power of 6. 6 times, which is a large number. I prefer the Sloan and Plouffe's superfactorial definition. What do you think? At number 8 comes the most interesting one, primorial. The primorial of a positive integer n is the product of all prime numbers less than or equal to n. It is denoted as hashtag symbol after the number. Mathematically, n primorial is equal to product of pi from I equal to 1 to pi of n. Pi of n is the prime counting function, which gives the number of primes less than or equal to n. For example, pi of 6 is 3 because there are 3 prime number less than or equal to 6. These are 2, 3, and 5. Let's see examples of primorial. In case of 5 primorial, there are 3 prime numbers 2, 3, and 5, which are less than or equal to 5. So, 5 primorial is equal to 2 times 3 times 5 equal to 30. There are 4 prime numbers which are less than 10. 2, 3, 5, and 7. So, 10 primorial equals to 2 times 3 times 5 times 7, which is 210. Let's discuss a different type of factorial, known as swinging factorial. The symbol used for swinging is called wreath product. The mathematical formula of n swinging factorial is n factorial over floor of n over 2 factorial, whole square. Floor function gives the largest integer not greater than the number. For example, floor of 2.8 is 2. Let's see some examples of swinging factorial. Floor of 5 over 2 is equal to 2. Therefore, 5 swinging factorial equals 5 factorial over 2 factorial whole squares, which equals 30. In case of 6 swinging factorial, floor of 6 over 2 equals 3. Therefore, 6 swinging factorial equals 6 factorial over 3 factorial whole squares, which equals 20. Finally, we have reached number 10, the last one, falling and rising factorial. Firstly, discuss the falling factorial. The falling factorial represents the product of n consecutive integers starting from x, decreasing by 1. It is also known as descending factorial or lower factorial. It is denoted as x subscript n or x superscript underline n, where x is the starting number and n is the number of factors. X falling n is equal to x multiplied by x minus 1, multiplied by x minus 2, and so on, up to x minus n plus 1. Here x should be greater than or equal to n. This can also be written as x factorial over x minus n factorial. Let's see an example. 5 falling 3 means 3 factors is used starting from 5, and each one decreases by 1 from previous one, and this is equal to 5 times 4 times 3 equals 60. You can also use the factorial formula, which is effective for calculating large numbers. Put 5 in place of x and 3 in place of n, you will get same result. Let's move to rising factorial. The rising factorial represents the product of n consecutive integers starting from x, increasing by 1. Also known as ascending factorial or upper factorial or Pochhammer function, is denoted as x superscript n or x superscript overline n. The rising factorial of x to n is equal to x times x plus 1 times x plus 2, and so on, up to x plus n minus 1. This can also be written as x plus n minus 1 factorial over x minus 1 factorial. Let's see an example. 5 rising to 3 means 3 factors is used starting from 5 and each one increases by 1 from the previous one, and this is equal to 5 times 6 times 7 equals to 210. You can also use the factorial formula, and this is effective for calculating large number. Put 5 in place of x and 3 in place of n, you will get same result. Thanks for watching. Don't forget to hit the subscribe button and become a part of PyLab for more exciting content.